we're going to say x to the fourth minus 6x squared minus 27 equals negative 35. So we have this in quadratic form because if you look at the pattern, our first degree is double our middle term, and this is to the 0 power here. So we have this in quadratic form, so we're going to go ahead and first set this up in standard form by setting our equation equal to 0. So we're going to have to add 35 to both sides. And when we do that, we have x to the fourth minus 6x squared plus 8 equals 0. And if you could see if you can go ahead and take this as a type 1 factoring. Does anything multiply to positive 8 but adds to a negative 6? So if you go ahead and look for some factors, let's see if this works out. Remember, this has to be x squared and x squared because it has to add to negative 6x squared, but it has to multiply to x to the fourth. So our possibilities here are 2 and 4, and they both are going to be negative since we're going to get a positive when multiplied. And if you look here, we get negative 4x squared minus 2x squared, which would give us a negative 6x squared, which is exactly what we need. So what we're going to do now is we're going to take each of these factors and set them equal to 0, and we're going to solve each one. So if I use the zero product property and I go ahead and square root that method and add 4 to each side, I'm going to get x squared equals 4 and x squared equals 2. And if I use the square root method here and square root both sides, remember I'm going to get 2 answers. Plus and minus 2 gives us 2 answers here. And if I square root both sides here, I'm going to get x equals plus and minus the square root of 2. We can't simplify that anymore. I do have 4 answers, and that's exactly what we need because this is the 4th degree polynomial. So our 2 answers are plus and minus 2 and plus and minus the square root of 2. So all of those are our answers. Okay, so that's part A. So this is the answer to part A. Part B is asking us to find the zeros of this function. Now remember, finding the zeros of the function is the same as asking for what values of x will f of x equal 0. That's what we're trying to find. So we're going to take our original function, x to the fourth minus 6x squared minus 27, and set it equal to 0 because that's what we're looking for. So we're looking for those zeros, which are the x values. Okay? So if we go ahead and see if we can factor that, we do end up getting a type 1 type problem. What multiplies to negative 27 but adds to negative 6 and factors nicely into 2 binomial factors, we're going to get x squared times x squared. It meets the pattern, okay, of a quadratic form. And we have negative 9 and positive 3 will multiply to give us negative 27, but adds to give us negative 6x squared. From this point on, we are going to go ahead and set each factor equal to 0 using the zero product property. And then we're going to use the square root method to actually solve for x. So if we add 9 to both sides, we're going to get x squared equals 9 here. And if we subtract 3, we're going to get x squared equals negative 3. Now, to solve for x, we're going to square root to both sides. So if we square root the left, we're going to square root the right. And taking the square root of 9, we're going to get plus and minus 3. And if we take the square root of negative 3, remember that this is the same as taking the square root of 3 times the square root of negative 1, which this stays the square root of 3, but the square root of negative 1 is I. So we're going to get plus and minus square root of 3i outside the radical sign. So 4 answers again. 2 of them are real. 2 of them are imaginary. We have x equals plus and minus 3 and plus and minus root 3 I. So there are 4 answers, okay? So those are finding the zeros of the function. Your homework would be 8.3, day 2.